So guys, welcome you all to this video. This is Q&A number 2 video regarding two problems. First problem, it is about sequence, and the second problem, it will be about series. Okay, so these two are you can say an interesting type of problem, and have a look on this. First of all, we are going to read these questions, and then you can pause the video and try it by yourself and check your answer and approach with my approach in the later part of this video. Okay, so let's start it. The first question, it says that basically for a and b belongs to n, consider the sequence that is dn equals to n a. Okay, that means nca and ncb for n greater than a and b, then which of the following is or are false. Okay, it says that the sequence dn will converge for all values of a and b. Then it says that will converge for a less than b, converge if a equals to b, and converge if a greater than b. Okay, so these are four options and you can try it. And the second question, it says that suppose we have a sequence, it is, let an be a sequence of real numbers satisfying this property. Okay, that is an minus a n minus 1, that is an minus 1, take the modulus, and this series, it is less than infinity. Fine, then the series summation an and x to the power n, where x belongs to R, is convergent where? First option says that nowhere on R, second everywhere on R, third on some set containing this interval minus 1 and 1, and only on minus 1 1. So what will be the correct option? Let's go to the solution part and try it. Fine, and you may pause this video now and try it by yourself. Correct. So first of all, the problem number 1, for the first problem we have dn. It is nothing but nca and ncb. We will use the formula of ncr, that is the formula for nca, and this is ncb, and do little manipulation, and finally you will have dn as this sort of thing. Correct. Now we need to verify whether a greater than b implies the convergency, or a equals to b, or a less than b. What will be the scenario? That's the simple case, and we need to verify all these things. For the first two, in fact first and fourth option, we can immediately take that a equals to 2 and b equals to 1, that is a greater than b. In this case we are considering. So here we will find that our d, that is dn, it turns out to be, for that particular choice of a and b, we have that dn turns out to be half into n minus 1, which is in fact a divergent sequence, which immediately says that for a greater than b, there is no question of getting convergency. So by this counter example, you can immediately discard your first and fourth option. Fine. Now for the case of a equals to b, then immediately what you have dn equals to 1, and which is in fact a constant sequence, and this is convergent. So see, it is true that for a equals to b, the series will converge. Correct. And in the case of a less than b, you will have just two little calculation, and you will find that dn will be of this form. That's the upper part will contain some constant, and the lower part will contain some terms involving n. Here I have just mentioned it by order of n. Correct. So as n tends to infinity, this fellow, that is dn, will converge towards 0. So it is the case for convergency. Thus your second option, that is B, option number B, it is also true, that will converge if A less than B. So in the problem they are asking which of the following is or are, I think it is false. Look at, it is false. So be careful with such problems, and here your first option, that is option number A and option number D, will be the false option. Okay, so these are your correct ones. All right, now we are coming to the second problem and its solution. So for the solution you can immediately take an example, and this example, it is, say we are considering the series an xn as 1 by n plus 1 into x to the power n. That means your an in this case, it is 1 by n plus 1. Immediately you can check that this fellow, that is modulus of the difference, and take the summation over n equals to 1 to infinity, you will find that this term. Okay, and if you are familiar with the series chapter, then immediately you know that this is a convergent series, so it is less than infinity. Fine, otherwise I will suggest you that go to the comparison test and verify whether this one it is convergent or not. Fine, now here we will use the concept of radius of convergence for this particular series, and for that the radius of convergence of that series, it is given by 1 by r equals to lim sup of modulus of a n plus 1 by a n. Okay, so use the formula and you have a n equals to n plus 1. So just determine this fellow and you will have r equals to 1. So the series converges, in this interval minus 1 and 1, and now you need to check at the end point, that is x equals to minus 1, you will get this sort of thing, and this is by Leibniz test for alternating series. This series will be convergent, and at x equals to 1 you will have this series. So this series it is, and by, you can say this is similar to 1 by n type of series, and this is harmonic series. So by that logic or by comparison test, you can immediately show that this series will divergent. That is your interval of convergency, it looks like this sort of thing. Correct? Okay, so what you are getting from this counter example, that you are getting this series will converge in this range. So it is not convergent everywhere, it is not convergent in the, I think second option says that nowhere. Nowhere convergence, it is false. Everywhere it is false. Only on minus 1 1 it is also false, because it contains minus 1 this part. Okay, thus you can immediately discard your first, that is option number A, B and D, you can immediately discard, and remaining option, that is the third option, it is going to be the correct one. Okay, by this technique, which is in fact option eliminating technique, you can also solve such problems in the exam hall. Okay.